tutorial, we will be discussing how to calculate the concentration of a solution. So when we're looking at concentration of solutions, the actual format is typically the same. It's the amount of the solute over the amount of the solution. Note the word solution. That is super important. That's where a lot of beginning students mess up. The solution is the solute and the solvent added together. That's super important, because if you a lot of students just want to divide it by the solvent, but really they have to add those two numbers together in order to get it. Now the other parts are just minor comparisons. For instance, mass by mass would be grams over grams, whereas volume by volume would be typically using milliliters. And then mass per volume would be grams per milliliter. And the molarity is typically only used for chemists, and that's moles per liter. So let's just start with the mass percent. Mass percent is grams per grams. Notice that the solute and the solvent are added together and then times 100, so you're getting your percentage out of this. If you're given a percentage and you're trying to get it out of a percentage, notice that they always put it in 100 grams of solution. That's because percentages in general are always out of 100. So if you get 85% on a test, you got 85 out of 100 questions correct. They always make it out of 100. That's by definition what a percentage is. So here, they've added 8 grams of KCl to this jar, to this beaker. They've added enough water to make that 50. So they ended up adding 42 grams of water in order to make that equal to 50 for the total solution. Let's do a practice problem here. We have 15 grams of sodium carbonate and 235 grams of just water. When we figure out the mass percent, we're going to add those two numbers together on the bottom. That equals 250. So it's actually 15 divided by 250 times 100. And that comes out to be 6%. Volume percent is the exact same thing. We're still looking at 100, but now we're doing 100 milliliters rather than 100 grams. It's the same typical process where it's the solute over the solution, the solute and the solvent added together. We're just basically looking at volume rather than grams. That's true with the mass volume percent as well. Grams of the solute over milliliters of the solution. So we're looking at the mass over the volume. So let's do a couple practice with these. Write a conversion factor for each of the solutions. So 8.5% by mass. So that means for every 8.50 grams of NaOH, there's 100 grams of the solution. That's all you have to do. 5.75% by volume, so that's 5.75 milliliters of the ethanol for every 100 milliliters of the solution. The ethanol and the water added together. 4.8% mass per volume, so that's 4.8 grams of HCl for every 100 milliliters of solution. Let's take a look at molarity. You may remember molarity, or moles in grams, from previous sections. Same concept, but now we're dividing it by 1 liter. It's always going to be per liter. So if you're given the grams, we have to figure out what the molar mass is in order to use it. So here we have what is the molarity of 0.5 liters of NaOH solution that contains 6 grams of NaOH. So 6.00 grams NaOH. We had to figure out the molar mass of the NaOH, and we know that by the key term grams. So Na is 22.99, O is 16.0, and H is 1.01. Add those together and it's 40 grams per mole. So grams are on the top, so I want to put grams on the bottom. And that comes out to be 6 divided by 40, which is 0.15 moles. So 0.15 moles over the liters, which is 0.5. That then comes out to be 0.30 molar. What is the molarity of 0.225 liters of KNO3 containing 34.8 grams? I see grams, so that tells me I need to figure out the molar mass when we're looking at molarity. Alright, so the molar mass, we have K, N, and O. We have 1 potassium, 1 nitrogen, we have 3 oxygens. Potassium is 39.1, nitrogen is 14.0, and oxygen is 16.0. We add those together, and it comes out to be 101.1 grams per mole. So if we have 34.8 grams, we can convert that to moles by dividing it by 101.1. That comes out to be 0.344 moles. Now we can use the molarity equation. Molarity is 0.344 moles over the volume in liters, which is 0.225. Divide that out, and it comes out to be 1.53. So this is just an example of the different types of solutions. We have mass per mass, volume per volume, mass per volume. In every single scenario, they're all out of 100, so we can use 100 when we're looking at conversions. Molarity, however, is out of 1 liter. You need to keep that in mind as you're using those. So let's try another one. How many grams of NaOH is needed to prepare 75 grams of 14% by mass NaOH solution? So we have 75.0 grams of solution that we're actually wanting. And it's 14%. So for every 100 grams of solution, we have 14 grams of NaOH. That comes out to be 10.5 grams of NaOH that we actually need to make the solution. How many milliliters of 5.75% by volume ethanol solution can be prepared from 2.25 milliliters of ethanol? That's the abbreviation for ethanol. So for every 5.75 milliliters, we need 100 milliliters of solution. So 2.25 times 100 divided by 5.75. That's 39.1 milliliters. Then one final practice problem. How many grams of AlCl3 is needed to prepare 125 milliliters of 0.150 molar? Notice it says milliliters. We need to get this into liters by dividing it by 1,000. So that becomes 0.125 liters. We have 0.150 molar. A couple different ways to go about doing this. I'll go ahead and use this as a conversion factor since that's what we've been concentrating on. For every 1 liter, we have 0.150 moles. That comes out to be 133.3 grams. I'm sorry, I skipped ahead. That comes out to be 0.01875 moles. We need to figure out the molar mass of ACl3. We have 1 aluminum and 3 chlorines. And aluminum is equal to 26.98. We add those together, and it becomes 133.33, which is the number I was writing down earlier when I said I skipped ahead. So we have grams per mole, 0.01875 moles over 1. For every 1 mole, that's 133.3 grams. Multiply that out, and it comes out to be 2.5 grams of AlCl3. And that's how you calculate concentrations.